As I told you guys, we are going to learn system of equations, and that is something that I did not decide by myself. I had asked you guys to send me a list of topics that you would want me to cover after going through the syllabus on Khan Academy, and some of you have given me a list of topics that you would want me to cover, and this is one of those. So we talked about circle theorem in the last class. Any of you have any doubt about circle theorem? Are we good, comfortable? Okay, all right. So today we'll talk about system of equations. So we'll start with system of equations. Let's see if we can finish it all in one class or it goes till tomorrow. But what do we mean by system of equation? I mean that's my style, right? I start with the very basic understanding of things. What is a system of equation, and why do we need system of equation? Yes, it's ready.
We use a system of equations to solve for two or more variables. Mostly two, though, I think.
Okay, so that is a definition coming from somebody who is educated enough. If I think about, I mean, I'm not saying I'm not educated, but I'm just making it up. So if I have to explain somebody what is a system, when you talk about a system, what do you essentially mean by a system? A software system, a hardware system, no, education system, whatever system you talk about, right? That gives you some output. Education system is meant for educating people, so there's an outcome from that. You talk about software system, it is built for giving you some tangible functionality or some feature that you can use for doing certain job. So any system that you talk about, that is meant for giving you something as an output, or there's some takeaways from the system. You don't develop a system which does nothing, right? You build an education system, nobody gets educated, no use, throw it away, right? So same way, when we talk about system of equations, meaning group of equations, multiple equations together, that gives you a conclusive view, an output or an answer to some of the basic questions. That's why we call it system of equations. We all have learned about linear equation, quadratic equation, and different things. But when you talk about system of equations, you are talking about group of equations that is meant for giving you a conclusive view of things. Relatable?
Yes, sir.
Okay. So now, everybody, right? I heard from Baba, but whoever is speaking or not speaking, I'm assuming that the understanding that I'm trying to enforce here, we are on the same page, yeah?
Yes, sir.
Okay. So, so we know equations. Let's say this is one equation. Everybody knows this is a linear equation, yeah, because the maximum power to the variable is 1. So it's going to plot a straight line. Let me try plotting it. But if I'm talking about just one equation, what does it do? It gives me, so let me go back to my earlier definition of equation. An equation is nothing but a contract. It's a contract or agreement or a deal between these two variables, where x and y have agreed that 4 times of my value plus 6 times of, let's say I'm x, and let's say Ritika is y. Okay, I'm just picking up name. Okay, no other reason. I'm x, Ritika is y. So I and Ritika have signed a deal saying that, okay, 4 times of my value plus 6 times of Ritika's value will give 13. This is a contract. This is a deal between me and Ritika. Okay. Meaning, if I increase my value, say no, I'm x, that is fine, but my value is 4. If I say my value is 4, this alone becomes 16. That means Ritika has to bring her value down. Yeah. If I say, okay, no, 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 I was very rude in saying my value is 4. No, no, I'm a very humble, decent guy. My value is actually 1. Now Ritika has an opportunity to increase her value. Now Ritika's value increases now. Because when I said 1, this became 4. And then remaining is 6y is 13 now. So y Ritika's value will be 13 by 6. Better than before. Right? In summary, what I'm trying to say is, any equation that you look at, you have different possibilities. When one value changes, other value changes correspondingly, or vice versa. And you can have n number of values. That is where you would have probably dealt with the table value for equation, where you will say, okay, fine. Now forget about Biren, forget about Ritika. It's x and y. If x is 1, then y has some value. If x is 2, then y has some other value. And then you make this table. What is the takeaway from this? You have multiple options to choose from. You don't have a conclusive view yet. Yeah? Making sense?
Yes, sir.
So if I have one equation, that gives me possibilities of solution. Possibilities of x and y combination that will agree to this contract. So, as I said, system helps you solve a particular problem. System helps you get an output. System helps you get to a desired state of what you're wanting to do. Here, one equation just gives you possibilities. It doesn't give you a solution. It says this could be an answer, 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 and so on and so forth. So you go to SAT exam, and the examiner gives you 10 questions to solve, and for each question you can say these are the possible answers for this question. You pick up question 1 and you give 5 possible answers. You pick question 2, give 5 possible answers, and then we know what is the score that I will get in SAT. Yeah. So that is where system of equations comes to our rescue. Say, okay, whenever you are dealing with too many possible options and not able to get a conclusive view, I will help you to get an answer for your question. And then that is when leaving one equation alone doesn't help you give an answer. So you come up with, let's say, another equation. Let's say, let me not put a quadratic equation for now. Plus 16y equals, let's say, 28. Now you have two friends working together to get a solution. This combination of two friends is called, two friends or many friends, is called system of equation. And I'm not saying that this will always give you an answer. This will always give you an absolute value for x equal to something and y equal to something. There are different scenarios that we might come across depending on what kind of equations we are dealing with. But then if you have a group of equations to deal with and group of variables to solve it for, then there is a possibility. And this group of equations is called system of equation. So far, any doubt with whatever I have said?
No, sir.
No? Sally,
No.
Sarah, Neil,
No.
okay. No question, Rehan, right? Okay. Now, I said when you have group of equations to deal with, there's a possibility that you might get a solution with exact value. If you get the exact value by solving the two equations, it is called consistent system of equations. When you have, let's say, since we are talking about two equations right now, let's relate it with two equations for now. If I have two equations with two variables x and y, and using these two equations I'm able to solve and get the exact value for x and y, then that is called consistent system of equations. If you want to visualize that in a graph, in a coordinate plane, let's say this equation plots a line like this, and this equation plots a line like this. They are meeting at one place, and the x and y coordinate of that point where they are intersecting each other, that is the solution that you will get. And when they are meeting or they have a common value, then this system of equation is called consistent. Clear? Now see, in when it comes to system of equations, there's nothing new that we are going to learn. What we are going to do is we are going to relate our understanding with, no, when we are dealing with multiple equations. So let's start with what are the things that we need to be aware of when we are dealing with system of equations. Let's say, if I ever say y4 always, let's say 17x plus y equal to 18. If I have an equation like this and I say, okay, solve it for x and y, you will not be able to solve. The best you can do is create a table with the possibility of possible values of x and y, but you will not be able to solve. What we know is, if I have two variables in the equation, or if you have to solve for two variables, we need two equations. If you have to solve for three variables, we need three equations, and that just goes on. So if I say solve for 6x squared plus 2y plus 7x equals 18. If I say just solve this, you're not going to solve this equation alone, because you see that there are two variables, x and y. So to solve two variables, you need two equations, and that is your system of equation. So that is the first takeaway, that you need as many equations matching with the number of variables that you have to solve it for. That part is clear to everybody, right? Yeah, Siddhartha, you are with me?
Yes, sir.
Okay. I'll keep on calling out random names just so that I get a confirmation that everybody in my class is with me. Okay. Now that is the first part, that you need as many equations as you have number of variables. Now second point, if I have any equation like this is one equation, and the second equation, let's say 2x squared plus 6x plus 7y equals 0 or 8. This equation is a linear equation. It's going to plot a linear straight line. This equation is a parabola, right? This will draw something like this or this, depending on how it is constructed. So this part we already know. Second thing or third thing, let's deal with the linear equations now. If I have two linear equations, meaning I can draw two lines, I mean we'll make the tables and draw them. If they are meeting at a point, the x and y coordinate of that point is my solution for this equation also. So you have two ways of solving a system of equation. You can either solve it in an algebraic way, or you can plot them on a graph, and wherever they intersect, find out the x and y coordinate. That is the value of x and y. Are you guys aware of all these concepts, or you would want me to touch upon that?
I'm aware.
Yeah, aware.
I know them too.
Okay. Sarah, Neil, you guys are aware too?
Yes, sir.
Okay. Alright. So this part we know that, okay, if I have two equations, I can either solve them algebraically, or I can plot them on a coordinate plane and then see wherever they intersect, find out the x and y coordinate of that. That is my answer for this one. You seem to be feeling sleepy. You did not sleep well?
I had brain competition in the morning.
Okay. If you need water or something, let me know. Yeah, fine. Okay. So this is the second thing. Third or fourth thing, I don't remember the number. Anyways, Now, I was saying that if I have two equations and they intersect each other, I mean that the line drawn by those two equations, they intersect at a point, that is my solution. And when they are meeting at a point, meaning by solving these two equations you get x and y value, this is called consistent system of equations. Now, what is the reverse of consistent? Inconsistent, right? Can somebody tell me when will that be a scenario when you will say these two system of equations are, I mean this system of equations is not consistent?
When they don't intersect.
When they don't intersect. That's an answer. Do you guys agree?
Yes, sir.
Now tell me a practical scenario.
Sir, I have another one.
Uh-huh.
So, like, when the equation is like, it gets like undefined. So
Okay.
that can also be like.
Right. So basically I'm just
Yeah.
relating these two things. Yeah, Ritika has to say something. Yeah, Ritika.
So when the lines are parallel,
Yes.
they won't like intersect at
They
any
will.
point. So
Correct. So basically,
that's when they're inconsistent.
yes. So when the lines are parallel, they will not intersect. So our thumb rule is if the lines are intersecting, that means we have a solution, and that is when it is consistent. If the lines are not intersecting, they will not be consistent. And the best scenario when the lines will not intersect is, or the only scenario when the lines will not intersect is when they are parallel. Right? That goes back to our basic understanding of parallel lines. So if you have two equations where both the equations draw a pair of parallel lines, that is when you are dealing with a scenario of inconsistent system of equations. Everybody with me so far? Okay. Now let's look at different techniques that we use for solving system of equations. What are those techniques? Yeah, let's go back to algebraic. So let's say algebraically if you are trying to solve a system of equations, what are the different techniques? I'll come to you. Let's see what response I get from the screen. Yes, Ritika.
Elimination.
Okay, that is one. Let's see what Chris has to say.
Use substitution.
Substitution, okay. And whoever has given, tell me.
Sir, you need to take one of the variable in the equation, like in both of the equation. To solve for another equation, you need to take like x first, and then after getting the value, and then you can substitute.
Right. So I think that's relating to one of the two techniques that I have heard so far, right? Elimination and substitution. Yeah.
Setting like x to equal like one of the y values, and then taking that and putting it to the first equation.
That is substitution.
Yeah.
Okay. Now let me tell you. I mean, again, substitution and elimination are two main techniques that we use for solving system of equations. But let me give you guys one more example, or something which is related to these two. My ultimate goal is always, see, as I said, if I have two variables to deal with, I need two equations. My ultimate goal is to use or do whatever beg, borrow, steal technique to finally come to an equation which has only one variable. That is my end goal. Whatever I have, I want to manipulate, deal with it, do some substitution, elimination techniques to finally convert or bring it to a situation where I have one equation with one variable. Let's say if I have 4x equal to 17, and to do nothing, I'll just say x equals 17 by 4. If I have 4x plus 16x equals to 40, I know that, okay, now I have come to a point where I have one equation with both the variables being same. I can just add them up together and I can find the solution. This is my desired state, or our desired state. My desired state could be different. I can afford to fail, you guys can't. So let's say this is your desired state. You're wanting to come to a point where you do some manipulation with whatever you have. And when I say manipulation, I'm talking about legitimate manipulation. Okay, don't make a mistake to manipulate things. We'll do legitimate manipulation to come to a point where we end up getting an equation or framing an equation which is having just one variable. That is our end goal. Okay, if we can get to this point, then solving it becomes much easier. Now let's talk about the two techniques that we heard: elimination and substitution. So who can explain me what is elimination in the simplest form? Ritika, you want to give it a try?
Getting rid of one variable.
Getting rid of one variable. So basically, if you look at both the equations, right, you have two variables in both the equations. Ultimately, you are trying to see how you want to knock off one variable so that you have one variable in an equation, and that is what I was saying, right? That is your desired state, where you want to come to a point where you have an equation with only one variable and a constant, and that helps you find out the value of the variable, right? Sally, here with me?
Yes, sir.
Okay. So, see, I'm a very creative teacher. I keep waking up kids one after another, okay? There's no pattern. You cannot predict that, okay, now Sally's name is called, so next is going to be Arya. Don't make that guess. I can call up anybody's name. So just let me know if there's something that is not easy to understand, okay? Alright. So, we are trying to eliminate one variable. Now before we do that, let's look at some of the basic concepts, and I'm pretty sure most of you are aware of it, but how much is there in the muscle memory is what matters the most for solving things faster. Let's say if I have equation like 4x plus 2y equals to 17. I always have the option of multiplying with any value. Let's say any value. I'll not say k, that will make it key variables and you guys will start worrying about it. Any variable, be it 2, be it 4, be it 6, be it 8, whatever. I can multiply this equation with any variable and nothing changes. Meaning, if 4x plus 2y equal to 17, then if I multiply by 2, it becomes 8x plus 4y equal to 34. And both are same equation, okay? Nothing has changed here. As long as you are multiplying all the terms with the same value, you're fine. You have not changed anything. And that is what I call a legitimate transaction. If you say, okay, fine, I'll multiply this by 3, I'll multiply this by 2, and multiply this by 4, this is illegal. You will not do it. Okay? As long as you are multiplying each and every term of the equation with one variable, one number, you're fine. Same way, you can always choose to divide also. You'll say, okay, fine, I'll divide everything by one variable, one number. Let's say 4, let's say 6, let's say 10. You can divide everything by one number. Each and every term gets divided by the same number. And you have not changed the contract of the equation. Okay? So, essentially what I'm trying to say is 4x plus 2y equal to 17 and 8x plus 4y equal to 34 are actually same equation. Okay? This understanding helps you, in a better way when it comes to the elimination techniques. Okay? Everybody with me?
Yes.
Okay. All right. So now let's come back to this equation. Let's see if I'm trying to solve this. Our goal is to knock off one of the variable. See, here you have plus y, here you have minus 7y. Okay? Meaning, if you multiply this guy with 7, this also becomes 7y, but that will be plus and this will be minus. So let's multiply this first. And when you multiply this, this becomes 7 6 is 42x plus 7 times y 7y equal to 17 7 yeah 139. Sorry, 119. to memorize table of 17 now. I was about to forget. Alright, so this is my, this equation became this equation. Basically I am saying these two are same. Now you already have this equation in place. If you add these two, what happens? And again, second thumb rule. You can add two equations, you can subtract two equations, you can even multiply two equations if you want to. Okay? And it doesn't do any damage. As long as you're not tempering the terms in between, you're fine. So if you have these two equations, that means if I can, now if you add them, this becomes 56x, 7y plus 7y minus becomes 0y or nothing, equals, add them together, 137. Now this became your derived equation which helps you get the value of x. Okay, and you use this value of x, you can substitute anywhere and gives you the solution. Now if you want to relate this with the graph that I was talking about, let's say these two equations are plotting these two lines on the graph, and this is the intersecting point. The value of x that you get here, this value and this one's coordinate will match. They're the same thing. Think about it again a little differently. I said if this is the equation, that means there is a contact between x and y to get this value. If x's value changes, y's value changes correspondingly, so that the overall result remains the same. Look at this one. Let's say this is the equation for the first one. Here the value of x is less, value of y is more. It's giving same value. If you come here, what happened? The value of x further increased. It was negative something, it became less negative, so it increased. So what happened? X's value increased, y's value decreased. So that together it remains this much. You kept moving. Here if you see, x's value is further increasing, and as x is increasing, y is decreasing. So that is the contract or the deal that they have between x and y for this equation. Similarly, on this line, so you have similar contract between x and y. One thing changes the value of the other one, so that the total value remains the same. Now, what does this point mean? This point means this is your intersecting point, which is abiding by this contract as well as this contract. Now you look at this point where your two lines are intersecting each other. This point is lying on this line as well as this line, meaning this point x and y value of this point is following this contract as well as this contract. That is how this is your solution. Moment of silence. Everybody with me?
Yes, sir.
Sunarka, Ishwari,
Yes, sir.
Sarah?
Yes, sir.
Okay. So, Rehan? With me? Okay. So basically, in simpler terms, if I have an equation that gives me a contract between x and y, and each and every point on this line is following this contract. If I have second equation which is drawing this line for me, each and every point on this one again follows this contract, meaning x and y keep changing their values corresponding to each other's change, so that the total is this much. And then when they are intersecting at a point, that point is common in this line and this line, meaning that point is valid in this equation, meaning that point's x and y coordinates are agreeing to this contract and this contract. That is how that becomes your solution. So different perspective, how you relate, that's what I was trying to emphasize here. Yeah. So if you look at this elimination technique, what did we do? We had one equation, we had second equation, and we know some of the basic thumb rules which says if I multiply an equation with some value, my equation doesn't change. If I divide each and every term of the equation by a certain value, my equation doesn't change. Or when I say my equation doesn't change, meaning my contract between the equation doesn't change. So it's like buying potatoes. If one pound of potato comes for $2, pound of potatoes will come for $8. That is what you're doing. But you're buying potato. Your contract is to buy potato. That is not changing. Just the quantity is changing. Yeah. Or it's a proportion thing that, I mean, any which way you can relate. So basically, applying that thumb rule to derive a third equation. If you have two equations, you're trying to combine them or play around with them to derive a third equation so that you get a simplified version of it to get the exact answer. Yeah? Praneet? Okay? Okay. Alright. So this is elimination. Now, let's go to substitution. Same equation. Let's say, or let's say different equation. 4x plus 3y equal to 18 and 2x minus 4y equal to 8. Or let's say this. If I have two equations like this, I want to solve. So first one was elimination. You can always say, okay, fine, this is 4y or this is 4x. I mean, you can always choose which one you want to eliminate. You can choose to eliminate y or you can choose to eliminate x. Let's say if you want to eliminate x, then what you have to do, multiply it by 4 and then subtract. Meaning if this is equation A and this is equation B, you multiply it by 4 and then subtract from this to this or this to this, any which way. And then you will be left with, one part will be gone and you will be left with the y. If you want to eliminate y, you will say, okay, fine, this is plus and this is minus. I'll multiply this equation by 4 and multiply this one by 3 and then just add them together so that these two get cancelled out. Then I'm only dealing with x and I can find out the value of x. So this is elimination technique. Now, the substitution technique that we talked about, meaning where we substitute the value of one variable for the other variable, or where I can find out the relationship between the two variables and then plug that value in the other one so that it becomes a single equation. I think everybody knows this one, but I'm just doing it for the sake of not assuming anything, and then we'll do some practice. So I have two equations. So from this, when we talk about substitution rule, I can easily find out the value